Something just moved at the edge of your vision. You didn't decide to react. Your body already did. Your shoulders pulled in, your eyes snapped shut, your hands came up, all before a single conscious thought crossed your mind. It was over in a fraction of a second. And now you're standing there, slightly embarrassed, heart hammering, because it was just a plastic bag caught in the wind. But here is what nobody tells you about that moment. That flinch was not a mistake. It was not a glitch. It was one of the oldest and most perfectly engineered survival systems ever built inside a living creature. And it has been running, uninterrupted, for hundreds of millions of years. Your brain did not protect you just now. Something far older than your brain did. To understand what actually happened in that fraction of a second, you have to go back. Not decades, not centuries, hundreds of millions of years to a time before your ancestors had eyes that could focus, before they had hands, before they had a single thought worth calling a thought. Early vertebrates, the distant ancestors of everything with a spine, lived in a world of constant ambush. Something was always faster. Something was always closer than expected. The creatures that survived were not the strongest. They were the ones whose bodies moved before their minds caught up. Neuroscientist Joseph Ledoux spent decades mapping what he called the low road of fear. His research at New York University revealed something that rewrote how scientists understood the human brain. When a threat enters your visual field, the signal does not travel first to your cortex, the thinking part of your brain. It takes a shortcut, a faster, older, rougher path that runs straight to a small, almond-shaped cluster of neurons deep inside your brain called the amygdala. The amygdala does not think. It does not weigh options. It does not ask whether the object flying toward your face is dangerous or not. It simply fires, and your body moves. The thinking part of your brain gets the signal roughly 200 milliseconds later. By then, you have already flinched. This is what researchers call the startle reflex, and unlike almost every other behavior you have, it cannot be suppressed. Scientists have tested this extensively. They have told volunteers, fully informed, fully prepared, that a loud sound is about to happen in exactly 3 seconds. They count down. The volunteers brace themselves. They know, and they still flinch every single time. Psychologist Michael Davis at Emory University spent years studying the startle circuit and found that it is one of the most conserved reflexes across all vertebrate species. Frogs flinch, fish flinch, birds flinch, reptiles flinch. The wiring is almost identical across hundreds of millions of years of evolution. That is not an accident. That is a system so effective that evolution never saw a reason to change it. Think about what that means. The thing that just made you jump at a plastic bag is the same circuit that kept your ancestors alive in a world full of things trying to eat them. Your flinch is inherited. It is ancient. It is, in a very real sense, not yours at all. But here is where it gets stranger. Your flinch is not just about physical threats. Research from the Max Planck Institute showed that the startle reflex is modulated by your emotional state. If you are already anxious, already on edge, already carrying something heavy that day, your flinch is faster, sharper, harder to calm down from. The amygdala is not just a smoke detector. It is a smoke detector that someone has been quietly turning up the sensitivity on based on everything you have experienced. Chronic stress, unresolved fear, a childhood that kept you alert, all of it recalibrates the threshold. The system that was built to save you can be tuned so high that ordinary life starts to feel like a minefield. And yet the reflex itself remains one of the most honest things your body ever does. It does not perform. It does not exaggerate for an audience. It does not lie. In that fraction of a second, before language, before logic, before the story, you will immediately start telling yourself about what just happened. There is only the raw signal. Something might be wrong. Move first. Ask questions later. Researchers studying trauma have found that one of its defining features is a flinch response that never fully resets. The body stays primed. The threshold stays low. The ancient system that was built for short bursts of danger gets locked in the on position. Peter Levine, a somatic therapist and researcher, argued for decades that the body holds threat responses in the nervous system long after the mind has moved on. The flinch in that context is not overreaction. It is memory, stored not in words or images but in the tension of muscles and the speed of a reflex. This is why two people can walk into the same room and have completely different bodies. Same space, same sounds, completely different nervous systems firing at completely different thresholds. What feels calm to one person feels dangerous to another, not because of what is in the room, but because of what the amygdala learned to expect long before either of them arrived. You do not choose your flinch, but your history shapes it. And here is the final thing. The thing that makes this not just a biology lesson, but something you carry with you today. The next time your body moves before your mind does, the next time you flinch at a shadow, a sound, a sudden shift in tone in someone's voice, notice what happens immediately after. Notice the story your brain rushes to construct, the explanation, the justification, the quick reassurance, or the lingering dread. That moment after the flinch is where you live. The flinch itself belongs to something older, something that crossed oceans and ice ages and mass extinctions just to keep your bloodline alive long enough to produce you. You cannot stop it. You were never supposed to. Something moved at the edge of your vision today, and you flinched before you could think. Just like every creature with a spine has done for the last 500 million years. The only difference is that now you know why.